Today you're going to learn how to create collisions between points, to make them not intersect with each other, to avoid overlapping. With this technique, you will be able to create animations like this one. So, let's do it. Okay, first of all, let's set everything, go to the notes, create a new profile. And I'm going to close this, and later we're going to use it, don't worry. Let's say this view, and I'm going to hide the grid, because I'm going to write something here. We don't want to use the cube, so let's delete it. What we want to use? We want to use points. So imagine we have a lot of points, and these points have a radius. We're going to try to represent the radius with curve cycles, so we can see better if they are overlapping. For example, if we have two close points, and like this, they are overlapping. Okay, so to understand the base, we're going to use the most simple example. 2 points with 2 radius, and try to see how we can avoid this. So to do this, let's go here and let's use 2 points. Let's add this node and make a copy of this. Let's connect it together with join geometry. Let's connect it here. And what I want is to represent the radius of both points with a cycle. Because a point, as you can see, is like a square. It has a radius like a cycle, but we cannot see it. So let's try to change this object, this point, with cycles. Instance on points, and let's use curve cycle. Right now we have 2 cycles. Let's increase the resolution. And which radius is the important one for this tutorial? This one or this one? The important one always are the points, okay? So we need to match this with this just for the example, don't worry, because if not, what you see here is not the real radius of the point. So let's add 1 and 1. Don't worry, later you can leave the default radius or have random radius. It's just to make it easier now. Okay, so we have 2 points. Imagine that this is the point with a location and a radius. However, right now they are overlapping. They are in the same position. So let's offset it 0.5 and this one the opposite, minus 0.5. To make it easy, right? We have 2 points with a radius of 1 meter and every one is offset 0.5 meters. Okay. So we have this, and now what is happening? That these 2 points are overlapping. They are intersecting each other. So how we can know that? We can know that because we can see it, right? And you are saying, yes, I can see that these are overlapping. However, how Blender, the real question is how Blender can know that 2 points are overlapping. Because Blender doesn't have eyes like us. So he cannot see this. He cannot see the patterns. He only reads numbers, data. So how we can say to Blender, hey, when 2 points are overlapping, do something. First of all, we need to understand when 2 points are overlapping. So let me draw here, for example, if we have a point like this and another really close, they are not overlapping. So this is okay, right? But also, if we have a point like this and a point like this, they are not overlapping, right? So this is okay. And if we have this, so 1 point here and 1 point here, they are overlapping, intersecting each other. Okay, so basically, we need to discover how to say this is okay and this not. So what we can do is to see this one when 2 points have the minimum distance to not intersect each other. In this scenario, we're going to assume that all the points have the same radius to make it easier. But don't worry, later you can do it with random radius. So if this is the minimum distance, imagine that they are touching each other. So if we have 2 positions, okay, this is position 1 of point 1 and position 2. And also what we have is the radius, right? The radius of each other. So let's call it radius 1 and radius 2. I know both are the same, 1 meter, but let's call it like that, okay? So we know that the minimum distance to not intersect is this one. So the length, the distance, okay, to not intersect is this one. Is when length is equal to radius 1 plus radius 2, right? If this happens, 2 points are not intersecting, overlapping. And this scenario is similar to this one, but the only difference is that the length is greater than this. So the length from here to here, the center, is greater than the radius 1 and the radius 2, right? Okay, so with this information, we can define when 2 points are overlapping. So when 2 points are overlapping, when the distance between position 1 and position 2 is less than radius 1 plus radius 2. So when this happens, the distance is less than this, means that they are intersecting, overlapping. So we need to write this with notes to create a condition. And when we have this condition, we have to say to Blender, when this happens, do something, do an action. So move the points in some direction. Okay. So let's try to write this in geometry notes. Okay, so let's move this. And first of all, what we want is to get the position of the point 1. Let's call position 1. And the position of the point 2. Let's call it position 2. Because we want to get the distance, the length between these 2 points to create the condition. So to get the position of all the points, we need this node, position node. With this, we access to the position of all the points. Okay, now, we also are accessing to this position. However, in our scenario, maybe we don't have 2 points. Maybe we have other points around. Something like this, one here, another here, etc. So we don't want to calculate the distance between all the points at the same time, because then this is taking too much computing for your computer, because every point is going to calculate the distance with all the points, and this consumes a lot of computation. Imagine if you have a lot of points. So what we want is to calculate only the distance with the closest point to each other. In this scenario, this one. But also, if we have here, for example, these 2 points, this one we calculate with this one. And the same for these 2, etc., right? So we avoid a lot of computation. Okay, so how we do that? To do this, we need to get the position of the closest point to all the points. And this we can do it thanks to index of nearest. So this node basically it gives you the index of the nearest index to another. Okay, but we want to get the position. So before this we need evaluate at index. This node evaluate any index of your scenario and give you something. So we want to get the position. That's why I'm going to select vector. We want the position. You can connect it here or here. It's the same. Now this is giving you the position of the index 0. But I don't know which index is this one, because if we have 100 points, I don't know which index is. So what I want is in relation with each point. So right now with this one, I want the nearest, the closest point to this one. So what I want is the nearest index. That's why I'm going to connect this here. Because thanks to this node that is really powerful, it's giving you only the index that is closer to this one. And the same for this one and If we have 2 points, this one will calculate this one, etc. Right? So with this, we are getting the position of closest point. Okay, perfect. So thanks to this, we have already position 1 and position 2. So now we can calculate the distance if we have 2 positions. How? Using vector math and select distance. You can also select subtract and then convert it with a vector math in length, but with this we avoid one node. So let's connect this here and this here, and now thanks to this node, it's calculating the distance between position 1 and position 2, but for all the points. Okay, now we have only 2 points, but for all the points. Okay, so we have this, the distance, the length, and now remember the condition. The condition was if length or distance is less than radius 1 plus radius 2, then this means that 2 points are overlapping. So if this happens, do an action, right? Do an action like, for example, offset, okay? Offset the points. Okay, so we have the length. This will be the distance or length. And now what we want is to create this. So create the condition. So if length is less than, let's use a compare node. Select, really important, less than. So if length, distance is less than this, so how we get that? To get the radius of each point, we have this node called radius. Easy peasy. This node is accessing, that's really important, to the radius of all the points, not to the instance, to whatever is something like that, a field. So don't worry if you have something like in this one 0.1 and this one 0.3 or random radius. Don't worry. Thanks to this node is reading all the radius of all the points that you have. So in this scenario, both points have the same radius. So we need to multiply this by 2 because it's 2 times twice this. So let's use math and multiply it by 2 and connect it here. So thanks to this, we create this condition, this rule. Perfect. If you want, I'm going to write here radius 1 plus radius 2. Okay, we have the condition, and now if this condition happens, please do an action. Move the points, right? So let's go here and let's apply this condition to move the points with set position. So right now we can move the points, but we only want to move the points if the condition happens. So let's connect this, the condition in selection. Okay, so right now, if for example, I select 1 in Y, they are moving 1 meter. Why? If I disconnect this, it's the same. Why? Because the condition is happening. So if the condition is happening, it's applying this offset. However, remember, I'm going to mean this. If the length is equal or greater than the radius 1 plus radius 2, it's not going to apply the condition. So let me move this, for example, this one like this, and now if I unmute this, you can see that it's not applying this change because the condition is not happening. Now I'm trying to show you how the condition works. So in the moment that this point is going to overlap this one, is going to be moved 1 meter up. Look, let's move this slowly and Do you see? So when they are overlapping, right now, something is happening. Right now, the action is just move 1 meter in Y, right? Okay, so understand how the action is happening. Okay, perfect. Now, however, what we want is not to move the two cycles like that, because they are still overlapping. What we want, let me unmute this, is to move the points in the opposite directions, because it's the easiest direction to avoid the overlapping. Because if you move the points, for example, this one here and this one, I don't know, here, they are going to be overlapping all the time, or sometimes like this. So the faster way to avoid overlapping is to move the points to the opposite directions of the closest point. So how we do that? To solve this problem, what we're going to do, let's unmute this. Instead of selecting as the value that we want to Blender calculate these directions, right? For each point, not only these two, for all the 100 points that we will have in our simulations. So we need to use vector math and select subtract. Don't worry, I'm going to show you why. We need to connect this in offset. And what we have to connect here? We have to connect in the top the position of all the points and subtract the position of the closest point to all the points. And thanks to this, look, I'm going to disconnect this and connect it. You can see, or actually, if I mean this is better, that we are moving all the points in the opposite direction. Don't worry, I'm going to explain you right now why this is happening. But I'm going to change something to not have too many wires here. I'm going to disconnect this and just bring here position, because this is the same like this. And what I'm going to do is to make it cleaner, something like that. Okay, so we are subtracting the position of all the points minus the position of the closest point to all the points. Why this is happening? Why subtract and not add? Why? I don't understand. Sean, can you explain me this? Okay, don't worry. I'll explain you right now. So let's bring a point here and let's use set position. Let's preview this. Let's show the grid. And let's see the difference between add and subtract in vector math. So here, let's use vector math. And now we have like two positions here. We are not connecting anything, but this is like two positions. So for example, let's select 1 meter in the first position. The first position is 0, 0, 1 meter. So right now, what we are doing is moving 1 meter, right? And if we add, okay, add one negative vector, boom, it comes back, because we are adding to this vector, right? Minus 1. So it's doing something like this. Coming back. This is what happens when we have a positive vector and we add a negative vector. Okay, so if we subtract the first vector to the second, okay, so instead of adding, we subtract, then the point is going like this. Because when you subtract a negative vector, it's like going in the other direction. So see the difference between add and subtract. So that's why when we had 0.5 and minus 0.5, so let's say 0, this is the original position, you remember, of the point? And if we subtract the position of the other point, that was minus 0.5, then this point is going to the opposite direction. And this one is doing the same, in relation to this point. Now you understand why we use subtract to subtract all the positions to the closest point position. So that's why we use subtract. Okay, so we just create this rule. However, if you want to control the distance that is being applied, what we can do is, after this, apply a vector math with a scale. So if you select 1, it's applying one value, one scale of this vector, but we can decrease this, for example, 0.5 or less. So it's applying this vector, but less or more. And with this, we're going to use it to animate in simulation nodes. So right now, you just understand the basics, how to avoid any point to overlap to another. By the way, if you're enjoying this tutorial, please hit the like button and let's continue, because now comes the interesting part. Okay, now let's apply the simulation nodes. So let's bring simulation nodes, and we want to connect the points to the input. And basically what we want is to add the set position, so all this in the middle of the simulation nodes, because we want to do this action, checking the condition for each frame. So each frame will do an animation, a movement, until the condition is not anymore working. So let me disconnect this, connect this here, connect this here, and connect this here. Let's move this and this here. So basically, we just add the set position in the middle of the simulation nodes. Now, let's bring back the timeline so we can see better the animation. And if we press play, nothing happens because the condition is not happening. Remember, the condition was if length was less than the radius twice. So that's why nothing happens. However, this is happening, but at the frame 1. Look, if I go at the frame 0 and I press play, it's happening, but only once in one frame, because in one frame is already breaking this condition. They are not intersecting more. So once the points are not intersecting, the movement, the offset, is not being applied. So for example, if you select 2, what is going to happen is that the difference between the frame 0 and the frame 1, so at the frame 1, as you can see, is applying twice this direction. That's why it's moving like that. So if you want to create a slowly animation to make it more beautiful, what you have to do is to decrease this number, so we can see better every step how it's moving a little bit every point. So for example, let's say something like 0.1. And now if we start from the frame 0 and I press play, we have this animation. If you want to make it slower, then decrease this, 0.01. Let's press play, and we have this animation. So you understand that this is like the velocity. But remember, if you want to make it faster, you don't have to scale this. What you can do is to increase the number of frames. So if we go here, and I say, for example, 60, and I press play, now the animation is faster. So you can play with this. Okay, let's come back to 20. And basically what I want now is to start to having fun with a lot of points. By the way, let's call this velocity. And let's do something. Let's make again the points have the default radius. So actually what I'm going to do is to use a grid. And let's convert this grid to, let me preview this. So let's add distribute points on faces. So we have a lot of points in a face, okay? Let's make this bigger. And let's add more density. So as you can see, we have points overlapping. Now, the important radius is the radius of these points that I think it's 0.5. So let's add set point radius here, and this will be the default radius. So let's update the curve cycles, because now they are too big. I think it's 0.05. So now the cycles have the same size than the default point. Okay? Very important. And now we can see, before we start the animation, that we have some points overlapping, as you can see. And now, if we press play, let's see what happens. As you can see, they are moving. Oops, let me remove this. If you want to make it faster, let's select like before 0.1, and we will see this animation faster. Actually, let's add more points. And look at this. Let's press play. And this is the final effect. This condition is being applied for each point. Each point is trying to see which one is the closest point to him and is trying to move in the opposite direction. So you can add more points, as you can see, and more density. And this is the final effect. Now you can start playing and have fun. For example, what we can do is to convert this grid to points with mesh to points. So now we have points to every point, every vertex, sorry. And let's decrease this. So we have this, okay, the normal points, but we can add more vertices. Something like this, for example. And let's decrease the size. Something like not 0. Okay, so always try to avoid that all the points are in the same position. Let's say something like this. And now let's press play. And look at this. All the points are concentrated in one single position, more or less. And now they are trying to move, push all the time. Okay, I need to add more time. And if you want to make it faster, remember, we can go here and I can select 0.2. And this is what's happening. All the points are pushing the other points until the condition is not working anymore and they stop. If they are overlapping, then they are still pushing the other points. And we have this really cool effect. Until, let me add more time. No, it's okay. Until in some moment it stops. So right now. So this is how you create this effect. Now if you want, of course, we can convert this curve to mesh and select, for example, I will use, I think it's better, instead of a curve cycle, use a curve line. And you have to decrease. So for me, what works is this one. But instead of doing positive, because if you do it positive, it looks like they're overlapping. So you have to make it negative, okay? Negative. Something like this. And now they don't overlap, okay? And what we can do, for example, is to give a material to this. Let's select this view. Actually, I'm going to make the background dark. And let's go to the shader. Actually, I'm going to do it here. Shader. And if you want to give, for example, a random value, a random color to each cycle, what you can do is to use object info and use this value. We are going to use emission. So, first of all, we need a color ramp, of course, because if not, we cannot give different values. But understand what is going to happen. If I connect random here, it's going to give a random value between these colors to, let me select 1, as you can see, to all the points. If I disconnect this, all of them are white, but if I connect this here, thanks to random, is giving a random value of this. So what we can do now is to change the colors. For example, let's select this color. Let's copy and paste it here. And now I can go here and select far. So it's selecting all the colors of this spectrum. Actually, all the width, because I select far. So far means that it's doing one full cycle. If you want to get the colors from one point to another, then select, for example, near. And I can select, for example, from here to here. And the points have different colors. And let's give in compositor some glow with a glare. And let's go here, of course, and select always. And select fog glow. Now I cannot see it, of course, because in the shader I have low strength. But if I increase this, we have this really cool effect. Let's come back to Geometry Nodes and let's see the final animation. Before we finish, I want to tell you some tips that will help you to improve your projects. So first of all, we can control the size of the cycles with the radius of the points. Because remember that right now we are controlling the size of our instance from here, as you can see. So we can do it with the radius of the points. So these always follow this radius. To do this is really easy. First of all, this leave it in 1, like by default, and we're going to use the scale of this node and use radius. If we use this node, basically the scale is the same as the radius of the point. But it's really important that always, if you use a cycle or a UV sphere, that is one value, because if not, it's not going to follow the same radius. So leave it in 1, and now the scale is the same like the radius of these points. So with this value, we can control the scale, the radius of the points. Perfect. This is the first thing. And the other thing I want to tell you is that how to make this animation faster. We know that we can make the frame rate faster, right? So every second we have more steps. Like right now. By the way, we cannot see that because I did something wrong. So let me increase this maybe. Okay. So if we increase the frame rate, of course, the animation will be faster. But what if I want to make it faster than this? I mean, we can select here this number or more, but there is a better way to do it, keeping this frame rate. So to make the animation faster, what we have to do is to repeat this process. Remember, this is the condition, and when the condition happens, it's doing for every frame this action, right? Moving, offsetting the points. However, we can say, instead of doing this every frame, can you do it more times every frame? How? With the node repeat zone. With this, we can repeat this process here a number of times. So let's disconnect this, connect it here, and let's disconnect this here. I know that sounds complicated, but trust me, it's not so complicated. And this here. So basically, we are repeating. Let me move this. The set position now is the same. It's just being applied once, for every frame, okay? Every frame, look. However, what I can say is, for every frame, move this twice. And now it will be a bit faster, as you can see. And you can increase this number as much as you want. So I'm going to exaggerate and select 10. That means that every frame is going to move to do this 10 times. So this is the effect. It's really fast, as you can see. So with this simple tip, adding repeat in the middle of a simulation zone, you are repeating one action more times for every frame. So with this will be the velocity too. This is how much. So let's say that this is how far is moving every step. And this will be the velocity. Velocity. And if you increase this, for example, it will move more far, as you can see. So we have more space between each point, as you can see. And if I say 0.1, we have less space between each point, each cycle. Now, another thing. It's true that I say that you can use different radius, so we can use here random value and give, for example, to all the points different radius. For example, something between this, I don't know, 0.2, 0.4. However, sometimes it's not going to work perfectly. Sometimes yes, sometimes not. I make some experiments, and sometimes if you make it too small, you can see they got stuck. It doesn't improve. However, if we keep always the same radius, it works perfectly. Okay, now it's too small. Let me restart again. So with the same radius, it works perfectly. With random radius, doesn't work perfectly. Maybe we have to do something else, but today we're not going to do it in this tutorial. And now, the final thing I want to tell you is that instead of cycles, what you can do is to use UV spheres. And it's the same because they have the same radius. And also what you can do is to, instead of pushing these spheres in this axis, let me disable the glow for now. What we can do, let's delete this and delete this. So let's use point, and what we're going to do is to add a point every frame. Remember, with joint geometry. So let's do this here. And it's really important. Now it's going to add a point every frame, but they're not moving because remember the rule. If 2 points have the same position, this condition will not work. So they need a little bit of difference in the position to work, because if not, they don't know in which direction it should go. So let's do here a random value for each new point. What I want is to select -1, and now if I press play, it's the same because every new point have the same position. So we need to use here a scene time frame. So every new point will have every frame at different position. Look. Okay. And they're going to push each other, as you can see, but let's make it better. Let's make all the points be concentrated in the middle. So they're going to push the other points in all directions. So how we can do that? Scaling this vector. Vector math. And let's decrease this like before. Something like, I don't know, 0.1. Let's try. And now if I press play, we have this really cool effect. All the new points that are being added are pushing the other points. So as you can see, with this setup, you can start playing and do really cool effects. So that's all for today. As you can see, this tutorial was a bit long, but you understand that there was a lot of theory and I wanted you to understand it perfectly because it's an interesting concept to learn. Because once you learn this, you can apply it and do really cool animations and simulations. If you like this video, please give a like, subscribe, and remember, you can do this project and many more than 100 on my Patreon. And see you in the next tutorial.